We're M.A.D lads, and this is our Vibes Check music application. The main problem that was associated with this app is that when users go to social gatherings, agreeing on the music being played can be a nuisance. Usually, one person controls the playlist on their phone, which means that others do not have the liberty to choose what plays next. This causes an experience where diverse musical tastes don't really have the space to be heard. Users want to be able to share music they enjoy, but there's no practical way to cue them in real time. Therefore, users need an app that allows for collaborative music control, where everyone can participate in selecting songs, vote on upcoming songs, and interact socially around the selected playlists. The general requirements for this app were that the system shall allow users to create and authenticate accounts with their email and password, allow users to create party rooms with settings such as name, visibility, and voting, allow users to join any parties by room code or public room list, integrate with Spotify's API to search and queue songs from Spotify's collection, enable democratic voting on the next song to play from the top queued songs, support real-time messaging within parties for social interactions, display the currently playing song with the song title and other artist information, maintain song history for both parties and individual users, store user profiles with customizable display names and profile pictures, support smooth navigation between party tabs, handle public and private room visibility options, and enable room discovery through browsing public parties. Users interact with the app through various input mechanisms organized into 5 categories. For authentication, users provide their email, password, display name, first and last name, and they can also upload a profile picture. For room management, they input the room name, select visibility as either public or private, toggle voting on or off, and enter room codes to join parties. Music control inputs include song search queries, selecting songs from Spotify's catalog, voting on songs, and applying genre or mood filters. Social features capture chat message text with automatic timestamp data. Finally, in settings, users can update their display name, email address, and change their password by providing their current password for verification. The app also provides rich outputs across multiple interfaces. Playback displays show the current song name, artist, and album artwork. The queue display presents an ordered list of songs with metadata tags and filtered results based on mood or genre selections. The voting interface shows the top 3 songs with album art, real-time vote counts, and confirmation messages for when votes are cast. Chat displays the timestamped messages with sender information and real-time updates as well. History lists maintain both party-wide song history and personal listening history with timestamps and artwork. Room lists show available public rooms and past parties with join or delete options. And throughout the app, users receive navigation feedback through tab indicators or success confirmations like added to queue or error messages like you already voted this song. The Spotify integration provides direct launch to Spotify for playback, OAuth authentication messages, and token storage confirmation. The code on the right demonstrates the input-output flow in the queue. Users input their search query in the text field, which triggers the Spotify API search. The output is a list view displaying the filtered results as cards, each showing the song's artwork, name, artist, and the dynamically generated mood and genre chips. Whenever they tap a song, it's added to the queue, and they receive immediate visual feedback through a snack bar confirmation. To solve the problem of collaborative music control, an app was built that connects users in virtual party rooms where they share a queue, and Firebase provided that real-time synchronization, making sure that all users see the queue updates, votes, and chat messages. And the architecture consists of 3 main layers. Flutter is what we use for our front end, specifically designed for Android applications. Firebase Firestore acts as our database backend, storing all of our party data, user profiles, queues, chat messages, and voting information. And Spotify's Web SDK provides access to their entire music catalog for searching and retrieving song metadata. The database is structured around lobbies, which represents party rooms. Each lobby contains nested subcollections for the queue, chat messages, voting data, and play history. And users also have their own profile collection that tracks their joined parties and personal listening history across all the sessions. This stream builder snippet on the right demonstrates the core of our solution. The snapshots method creates a live connection to the Firestore database, listening for any changes in the queue collection. And whenever somebody wants to add or remove a song, the stream builder automatically rebuilds the UI with the updated data. We order songs by timestamp to maintain fair play order, and the list view builder creates a card for every song, displaying its artwork, name, and artist. This real-time synchronization is what enables true collaborative control so that every participant in the party can see the same queue at the exact same time, and anybody can add or remove songs with changes, syncing instantly to every single device. And this solves the original problem of single-person music control by giving everybody an equal input. These are our key design features. The first one is our real-time voting system. I did not personally implement this one, but the way that this works is that the top three songs from the queue are automatically synchronized to a dedicated votes collection in Firestore using a real time listener. When voting is enabled, users see a dialog displaying these three songs with their album artwork and current vote counts. Users tap on their preferred song to cast their vote, and Firestore's field value.increment is used to update the vote count, which prevents race conditions when, multiple users vote simultaneously. Once voting ends, the song with the highest votes play next, and it gets removed from the queue. The system also tracks whether each user has voted using a can vote Boolean flag, which resets when a new song begins playing, ensuring that everyone gets to vote on each round. And this kind of helps ensure that the voting system is purely democratic. Second, the mood and genre based filtering system. This feature helps groups find songs that match their party's atmosphere. The challenge here was that Spotify's track search API doesn't really directly return mood information with every song, so to solve this, I made additional API calls to fetch genre data from each artist's profile, and then I mapped those moods to genre categories. So, like, if an artist genre had words like pop or dance, I would tag it as happy, rock and metal map to intense, and then sad and blues map to sad. And these mood and genre tags are then displayed as colored chips below each song card in the search results. And users can tap on filter chips to narrow down the results in real time, making it much easier to find songs that fit the group's current vibe without scrolling through hundreds of irrelevant tracks. Third, the dual history tracking system. This maintains a record of all music played for both reference and discovery. There are two separate history collections, one at the party level that tracks every song played during that room session, and one at the user level that tracks each individual's listening history across all the parties they've joined, which is the one that I focused on implementing. Both use Firestore timestamps for chronological ordering. When a song plays, the add to history function is called, which writes to both collections simultaneously. This dual approach serves multiple purposes. Users can revisit songs they enjoyed and discover what was popular in previous parties that they've attended or hosted, while party hosts get a complete record of their sessions playlists. The history displays song metadata, including artwork, artist name, and the exact time it was played, creating a persistent music memory that enhances the whole social experience. There are two code snippets on the site as well, and the top one pertains to how moods are associated with specific genres. Like if it says if genre contains pop or dance or happy, then the mood is going to be happy. Same with if it's chill, the mood's going to be chill. If it has rock, metal, etc., etc. And then if it doesn't have any of those, it's just going to be neutral. So if you see any songs that are tagged as neutral, it's because it didn't really fit into one specific box. And then the bottom one deals with how songs in the app are added to the history through Firestore.
So for our design and UI, we decided to have the design mainly inspired by Spotify, given that this app is primarily built on the Spotify API, and it serves as a music player. We opted to follow in similar design choices, mainly being a majority dark body color. On Spotify, most of the background and most of the screen is just black, and we also kept the bright highlights for important features such as buttons. But we also wanted to maintain the same sort of simple UI that Spotify had, um, and we wanted to also keep it simple for an easier user experience. So we wanted to not have a lot of buttons on the screen underneath um, any sort of like card, like a lobby card or a song card, anything like that. We wanted it to be just visually clean. So instead of having a bunch of buttons under something, uh, we would use something like inkwells, so the actual card itself is the button. Or if we had to have an additional button for something like deleting a song from the queue, we would include that button as a trailing button within a list tile instead of having it floating off underneath it or to the side. And on another note, we made sure that the shapes of a lot of the objects in the app were just kept simple. Uh, for example, the lobby cards were kept very concise. We didn't want to overwhelm the user with information. We just kept it as a simple, um, rounded rectangle card with just little information, simple colors, nothing crazy. And lastly, to for the UI, we went for a tab layout as well as an additional drawer that the user has access to on a variety of screens. And the tab layout makes it easy for the user to access important screens um, from their current screen that they're viewing. So, for example, on the home screen, you can view the relevant parties list, past parties list, as well as your own personal songs. But for something like the when you're in the actual party screen, you have access to the queue, the song, and the history in the chat for that screen. And this with the drawer, we also allow easy access to a variety of settings or to return at any point wherever you are on the app because the drawer exists on the majority of screens. So here is our UML class diagram. It's a little bit of a mess because there are a lot of interconnected functions and screens, but starting from the left-hand side, that cluster of 3 classes, that is where you're first introduced to the app and setting yourself up to use the app. So we have the class splash screen, or just splash. This is just the first screen you see, and it has 2 buttons that allows you to navigate to the sign up and the sign in. And in the sign up page, you have some variables for just form validation and the function to sign up, which creates an account with Firebase authentication and stores relevant user data in Firestore. And once you have an account signed up, you can sign in again with the same form variables. And when you sign up, you are able to navigate to the home screen, which is the first main piece of content in the app. So from the home screen class, it has a tab controller. So there's a tab display here, with 3 main tabs, which are built up by the classes: group list screen, party list screen, and song history screen. And this has a few functions here for generating code, random codes. This is for IDing lobbies, as well as other relevant functions such as format timestamp, which is for populating certain timestamp related fields. And then we have the ability to create lobbies and join parties. So the first of the tabs is the group list screen. This doesn't have any particularly relevant functions or data, but it does just contain a stream builder just to build content for a group list. So it gets the group's data from all the lobbies in Firestore. Next is the party list screen, which is kind of the same thing, but this one is just retrieving previous parties for the user from Firestore. And what's interesting about these 2 classes is that they both pull from the lobby card class, which is just a sort of placeholder card for lobby data, which these pull from Firestore and then populate into those cards for the stream builders. So a card is generated for each lobby in the list. And lastly, there is the song history screen, which has relevant variables for playing audio or playing previews. And that again builds content for one of the tabs on the home screen. Another part of the home screen is the drawer, which this extends to 2 different classes to the 2 main screens, like sections of the app. And this is just for the drawer that lets you navigate between important tabs. So the drawer is able to, it's building content for both the home screen and party screen, and it allows you to navigate to the profile screen and the settings screen. And the profile screen is used for modifying your profile details, such as your profile image and display name. And the settings screen is used for managing your actual account information. So this is your name, password, and email, and also lets you sign out, which returns you to the splash screen. From the home screen, you can use the join party function to make your way to the party screen, which when you join from the home screen, it uses the lobby code you get to go to a specific party screen of said lobby ID, so it shares all the lobby ID information. So from the party screen, we have a couple strings related to the Spotify SDK, the client ID and secret client ID. Those are important for getting authorization from Spotify to allow the app to access information, as well as other management variables such as the current song, the voting, as well as getting the current song and authorization. And just like the home screen, this has tabs. One of the screens is the song screen, which has a lot of relevant song information. It has a listener. It shares the can vote variable as party screen to make sure the user is able to track their vote, so they can't spam vote. They only get 1 per song or per play, and it of course resets between plays. And it also has the relevant functions to get the top song in the queue and play that song and add it to the history, as well as pull up a menu to allow the user to interact with the stuff. The next screen is the queue screen, which contains a lot of the variables required for tracking any filters or any search fields, and again some functions for searching, as well as functions for adding to the queue, and again getting the access token to actually use the Spotify API. Another screen is the chat screen. This handles the messaging between users, but surprisingly, it does not require that much in terms of variables since it gets just most of its data from Firestore. So it gets the Firebase authentication as well as a function for formatting timestamps for messages. And then lastly, we have the history screen, which is similar to the one in the home screen. It just manages the songs in history, but this one being personalized for the party, not the user. So it contains similar functions. Now, you might have noticed that there weren't many public fields here. Thankfully, this is due to the fact that the project relies on Firestore, that it does not need to share this data between each class because it can just pull it directly from the Firestore. So here is some pseudocode for how the app works. So as discussed previously, the sign up screen is where you sign up. There are form fields there where you can create a new user using Firebase authentication, and then you can actually create a user with all the details in the Firestore. Sign in screen, it's the same sort of process. You use form fields to get information, Firebase authentication to set the user and authenticate, and then from there you get to the home screen. So on the home screen, you have a set of tabs, the list screen, which is the lobby list. This has a form for entering lobby IDs. We have a join lobby button to join lobbies, and we have the ability to create lobby, which does so by generating a random 6-character code, and assuming that's not already taken, it will create a new lobby in the lobby collection, and then we'll navigate to that newly created lobby. And this list screen will also contain a stream to get the list of lobbies that have been made, and we'll generate a lobby card for each of those lobbies. And these cards will not display lobbies that are private, so those will be excluded. Then we have the party history screen. This has a stream builder which just generates lobby cards for each lobby that the user has joined. So each lobby is stored in the user's personal party history. And again, it's the same deal for the song history screen. For any songs you've listened to in past parties, they will be stored in the Firebase user song history, and there will be list tiles for that for each song. So onto the next screen, we have our main lobby screen, the party screen. We have 4 tabs here, starting with the song screen. This is where the music is played. It retrieves the top 3 songs from the queue by position, so the next 3 songs that would be played. And from the vote menu that gets opened, they are listed with inkwells in which you can tap to cast a vote towards them, which updates the count in Firestore to keep this vote number synced. And after the votes are cast, you can play the song, which it gets the top song from those votes, and this song is then passed to Firestore to update for the entire lobby. On the queue screen, we have the Add to Queue button, from which it opens up a search menu where there's a text field as well as mood and genre buttons, which you can enter in your information or select what mood or genre you want. And from there, the songs from Spotify get listed in accordance with the search bar details as well as any active filters from the mood and genre. And outside of that menu, the main content is populated by Stream Builder, which produces all the queued songs as list tiles, with the relevant information being the image and artist name. From the message screen, we see a Stream Builder, which just retrieves all the relevant data from the messages collection in the lobby, and from there the message list is produced, and it moves the messages and orients them with the proper information as well, based on the user. So if you are looking at someone else's message, it will display their name, their profile pic, and their message on the left side. But if you're viewing your own message, yours will have a different color with you instead of your name, and as well as your image. And then we have a text field which you can enter your message into and submit with that to add to the messages collection. And then lastly, we have the party history screen, which again uses a stream builder just to get the history list, so the list of previously played songs, and just lists out the tiles for each one of those songs. So when it came to testing, it wasn't anything too special. We just created, sample test accounts and lobbies to sort of fill up the list that we could move into. So, for example, I just did t@email.com with password 123, nothing crazy with just filler information, and then of course, um, just generate lobbies to see how they interacted with the streams to see if they properly generate and hold their own unique data. Um, During our development and testing, there were certain features that we just couldn't make work for one reason or another. Either they were just difficult and didn't want to function, um, or just Spotify SDK did not support them. So, for example, if previews was one of the requirements, and we have the code to support previews, but unfortunately, I think Spotify themselves actually do not allow that does not allow the Spotify SDK to play in-app previews, which is a shame. But so we had to fall back to just opening the song if you click on it in your history. Another feature was autoplay. For whatever reason, that didn't want to work. There's some difficulty in managing just the Spotify player in relation to the app, so it was difficult to read whether it was still playing, it was paused, if it was finished, so it was difficult to actually initiate another vote or move on to the next song. And lastly, was the most disappointing was the in-app song playing. This is just straight up impossible, I believe, with the Spotify SDK on Android. I think there's a way to do it with a web view, but that didn't work out, and every other source I've seen just says Spotify just does not want independent developers like playing in their own app using their stuff. So to summarize, what we learned is we gained knowledge through our extensive use of Firebase features. So we made heavy use of Firebase authentication in order to manage our users, and we gained a lot of experience with using Firestore for relevant data storage. Much of the information is just retrieved from Firestore. It's not passed between screens, or set state is not used too frequently. Most of the updating is done using stream data to, so we'd have like stream builders for retrieving user data, or we would have asynchronous functions to retrieve user data, and we'd have streams for lobby data such as the chat or the queue, which would automatically update. And on top of that, because we were using Stream Builder and Firestore data that could be accessed anywhere, it made it easy for data synchronization. And we also gained some experience with the Spotify SDK usage. So that was Spotify authentication, so we were able to actually like connect with the Spotify app from our app, as well as manage the Spotify app from our app. However, it wasn't all smooth with the learning process or usage of the Spotify SDK. There's just a lot of problems with implementing the free features, as discussed prior, just with features that weren't supported anymore, such as the previews, just other features that did not want to work one way or another, being, the autoplay or just any sort of way to detect the status of the song you're listening to, and just other features that are not allowed, which is the in-app playing. So with that out of the way, here is our link to our GitHub repo, and here's our demo. Hello, hello, hello. Okay, so here we are with our demo. Here's the splash screen. We can set up our account here. So let's go ahead and sign up. If we enter with nothing, as you can see, the form attempts to validate. So let's go ahead and enter an email. Let's do first email, email.com. We'll do new name, test F, test L, pass 123. There we go. The registration was successful. If we go to our users, yes, okay, yeah, it's this one. As you can see, this is added to the user collection. Let's go ahead and do first email at email.com, pass 123. It signs us in. To start off with, let's open the navigation bar. This brings us to a list of screens we can access. This group list button just takes us back home. The profile screen here, we can change our name, so let's do new display name. We can update display. As you can see, it changed over here. If we select an image, right now the image is null because there's just a default placeholder image. We can go ahead and save this image, and that updated the image URL as well. So let's go ahead and go back. We can go to the settings screen now, where we can modify our personal account details, so we can change our name. So let's just do new F, new L, update first and last name. As you can see, it updated there. We can update our credentials, which which requires us to have our old password put in. So let's do pass123, and then the new one will be pass. Let me make sure I type this in right so I don't mess it up later. Pass1234. So we can update the pass. There you go, it updated. If we want to update the email, we need to have the password as well, and let's update that to the new one. Let's do secondemail.com, or sorry, second@email.com. This processes, and now the email is updated. If we hit the sign up button, it sends us out our account, brings us back to the splash, and we can then sign back in with our new information. So now we are in again with this account, and it's the same one. You can tell because the profile pic is the same. So we just changed our account information. So here is the home screen. We have access to the home list of lobbies. We can enter a code and join a lobby, host one, or join one of these public ones. It does not show anything that's private. We go here. This is our party screen where the past parties that we've joined are shown, public or private, and then our history for any songs that have appeared here. So let's go ahead and join a room. Let's do this one. I've already connected to Spotify, but there is a button here to authenticate with Spotify, which will bring you to the browser to allow access to your account. And you might have to get a code from your email, enter it in there. We can look at the party's queue, the current song that's playing. We can look at the voting menu. There's nothing in the queue, so there's no songs. If we go to the chat, we can see there's multiple users chatting in here already. Let's say hello back. And because we are the one that sent a message, it's on a different part of the screen, as you'd expect, and then the pass songs for that room. And if we remember this code, DLP VDL, we can join this party. And if we go back to the group list, we can see it's listed here. It's not duplicated. So let's go ahead and actually make a party. We can go host. We can call it fun times. If we go to private, create it, and go back, we can see that it's not actually in this list because it's private. But if we go here, we have a private room that we can access. So right now the queue is empty, so let's go ahead and populate it. So let's just search up an artist. So let's do this. As you can see, we have some songs. Let's go ahead and select that one. And it pops up in the queue. Let's do, this time, just a word, and we can select different genres here. Here's a Christmas one, so there is a list of songs here, but if we select Christmas, you can see it filters to just this one that says Christmas. So let's go ahead and add that. And let's search up a title. Here we go. Let's go and add that to the queue. Alright, so now that we have our queue populated, you can see nothing's played yet, so there's nothing in the history. If we go here to go to the voting, we can actually tally the votes. We click on it, we cast our vote. If we open it back up, we can see that now has our vote, and we can't vote on anything else because we've already voted. If we hit next song, that'll go ahead and open up the Spotify app. And from there, it should start playing the song. This emulator is melting my PC, it's not happy. So, and there you go, it starts playing. Let's go ahead and pause this. Please. Okay, thank you. Yeah, it is not happy. But if we go here, as you can see, it updates. It tells us what song's playing. We have a play button to resume playing it. Gives us the album cover and the artist name. As you can see, it disappeared from the queue, and that the new songs started playing. We can cast another vote and play another one if we so wished. And if we go to the history, you can see it updated here. And if we click on this, this would be a preview button, but unfortunately Spotify does not allow previews anymore in apps, so now this just takes you to the song. If we return to the group list, you can see our history is now also updated. And again, if we go ahead and click on this, it'll take us to the app, but hopefully it does not kill my laptop. Oh, it crashed. Okay, the emulator is not happy. All right, that's fine. But that about sums up. As you can see, uh, a lot of relevant user information is stored in the Firestore. If we go to the database, go to our users, you can see there's a lot of fields for or collections associated with the user to store what they need. So we have access to the history of songs, history of parties, and of course parties has, let's go back, lobbies, excuse me, has access to its own set of information. Alright, but that about wraps it up. Thank you for watching.